Go ahead and write down the following information. This is another problem that we're going to continue. If you noticed, I added a homework on your homework, and I deleted, or I made the other homeworks in Chapter 10 unavailable. So you should be working on one homework. I've also enabled the last test and the final exam. So some of you may not have to come back Tuesday. It's up to you. Okay? Tuesday is what? Thank you, one person. So please, if you don't want to be here, don't show up, okay? I will be here to answer questions, homework questions. That's what I'm going to go over is homework questions that day, so that's all I'm going to do. But this test, this last test and the final exam will only cover the kind of questions that I'm covering, okay? So Chapter 10, I did several problems with you the other day, and I'm going to do 4 today. And that's pretty much all that's going to be on the test. So don't spaz over this last test. It's not going to be that big a deal. If you can do the Chapter 10 homework that I put on the homework assignments, then you can do it. So everybody should be writing this down. That means everybody. The outside diameter of a part must be 1.3825 units. I don't care what the units are. This isn't science class, so I really don't care. In accordance to specifications, a sample of 10 parts were measured, and those are the 10 parts. Now, why am I showing you this? Because sometimes on a standardized test, instead of the information being given to you, like inferential statistics, you're given data-driven, and you have to find the mean and the standard deviation. Now, the first thing you're going to do is state your null and your alternative hypothesis. And go ahead and find X bar and standard deviation, because you're going to need it. Now, I probably will not give you one of these on test because it'll take too much time to do. But I wanted to give it to you because you might see one like this on a standardized test. Now, you're not going to use a test statistic because it says use a 95% what? Confidence interval. So they want you to put this to see if this is going to fall in the gap in the confidence interval. So that means you got to use that chapter, whatever, 9 material where you find the what? Margin of error and the what? The p-value. Now, you're going to use the t because what's not given? The population standard deviation is not given. So you're going to use the t-value. I'm sorry, I said p-value. It should be t-value. So go ahead and find the mean and the standard deviation. And yes, I do expect for you to use your calculator, not do it by hand. So go ahead and find your one variable statistic and find the mean and SX. No coughing in class. Do you have a class downstairs?
No, it's upstairs. It's green.
Okay, well, some other person thinks I'm totally weird then. Because there's somebody that was in the class downstairs and it's right beside my class, and I thought it was you and I waved at you, and I guess they think I'm some kind of crazy person.
I do that all the time.
Okay, what, think I'm a crazy person? Well, at least, you know, I try to be polite.
Standard deviation over his X examples 10, and then N.
Now, when you do your mean and standard deviation, which you should have typed it in by now, you're going to get a mean of, I got 1.3826.
Yes.
And a standard deviation of 0.00033. While we're at it, let's go ahead and write down our degrees of freedom. Our degrees of freedom is 9. And our null hypothesis, what does it say right there?
What must be?
Exactly, what it must be. So that means our mean, our population mean, which we're given the sample mean, so we're doing everything in terms of the population mean, it's got to be equal to 1.3825. Now, does anything in the problem say anything about being greater than or less than?
No.
So what does that leave? If nothing in the problem says greater than or less than, then what does that leave? Does not equal. So the alternative hypothesis is does not equal 1.3825. Okay, so now we've got our information down. Okay. Now there's two things in this problem that you have to look for. One, what does it say? It says use a 95% what? Confidence interval. Have we seen anything like that before? No. So that tells you that you're not going to do the traditional, testing. You're not going to draw the picture. You're not going to draw your critical region. You're not going to calculate your test statistic like we've been doing and like you're going to do today. All right? This is a different problem. Kind of like that problem, you know, the problem that we typed in NPX because we didn't have enough information, so we used binomial distribution. That's one of those that I won't test you on, but you might see on a standardized test. Same thing here. They give you a confidence interval. That means, okay, this is a different type problem. You're going to check the upper bound and the lower bound and see where it fits. Now you got to find your t value. Okay, now there's two ways to find the t value. One is on the calculator, and I'll show you how to do that in just a second. The other, and you can find it if you go to stat test, you should see a t-test, and you just have to type in what you need to, but I'll go over it. Another is to go to what? The table. And for those of you that have a table, I didn't write down the table, but the table gives you 9, there is a 9 degrees of freedom, and then you look for 0.025. Why 0.025? Well, alpha, I forgot to write this down, alpha is equal to what? Somebody tell me what alpha is.
Complement
Of, which is 0.05. But this is a what tail test? This is a two-tail test. And whenever you have a two-tail test, you don't use alpha, you use alpha what? Divided by 2, which is 0.0 what? Now, you don't have this on your card because you don't have a t-value. Now, it might behoove you to print out a t-table or make sure you know how to use the calculator. The only reason you need to print out a t-table and a z-table is because on some standardized tests, you're not allowed to what? Use the what? Calculator, and the table is given in the question. So you need to learn how to use it. So the two-tail means 0.025, and you follow that down, and follow that down, and you get a t-value of 2.262. Now, somebody take your calculator. I'll go ahead and put this down for you. The calculator, go to stat, test, t interval, and then data, because data means what? Means you have what? Data, Hubert. That's right, class. Okay? Statistic means that you're given the mean and the what? Standard deviation. So you don't have to find the mean and standard deviation if you know how to use your calculator. And frequency 1, C level, confidence level 95, and calculate, and you should get the interval that we're fixing to get. So the lower bound is 1.3826 minus 2.262 0.00033 over the square root of 10. And of course, that's going to be the same thing down here. It said plus 1.3826 plus 2.62262 0.00033 over the square root of 10. And the lower bound is 1.3824. And the upper bound is 1.3828. So our mu needs to fall between those two. Does it? Yes. So you do not reject the null hypothesis. So write that down. It falls within the 95% confidence what? Interval. This right here is the 95% confidence interval. You just calculate it. And your mean right here falls within that. So therefore, you fail to reject the null hypothesis. Now, this is a problem you might see in the homework, you might see on a standardized test. But I thought it would help you. So you got two problems that might be on standardized test. One is the binomial distribution, so you need to mark that in your notebook. The binomial distribution, the one we did MPX 16 and above. Remember that one? I done forgot what the question was, but it was 16 and above, and we found the cumulative of 15 MPX, and then we subtracted that from 1. Was that the last one we did, or second to the last one we did? We'll find it, put a highlight on it, and say possible SAT, possible standardized test question, whatever. Okay? This is your other one. Now I've got 4, I think, questions that are nothing but test questions. I think I got 4, maybe 3. Yeah, 3. Okay? And all of my test questions pretty much are going to follow these type lines, except for the, basic formula, find this, find that. It's, some of them are pretty simple. The only part of your Unit 3 test that would be difficult is these questions, in which if you follow the steps that I give you, you'll be all right. Okay? So, let's go ahead and work on these. Suppose we sample 35 values. Suppose we sample 35 values. We wish to test the following H of O, mu is equal to 100, and H of A, mu is not equal to 100. So at this point, you know it's a what?
Two-tailed test.
Two-tailed test. Thank you. Two-tail, therefore, alpha over what? 2. Sometimes they're going to give you everything, and all you got to do is put it together. In this type question, they're going to give you, the null and the alternative hypothesis. X bar is equal to 104, and SX, or S, is equal to 12. So at this point, it's a T statistic, or test statistic is going to be T because of what? There is no what? There is no sigma, therefore you got a T value. So degrees of freedom, therefore degrees of freedom is equal to 30 what? 4. So it's time to draw a picture. So go ahead and draw a normal curve. And when you do your T value, you should get 1.972. Go ahead and check it. t-value. I didn't write all that down. And in this type question, they just want to know where is the rejection region. So, or, yeah, that's what they're going to ask, some type of question like that. So, let's say 100, and the standard deviation is 104. Okay, it doesn't matter, they want t-values. So that means that I got a t-value of 1.972. T-value of 1.972. So that means 1.972, 0, 1, 2, 3, -1, -2, -3. So 1.972 would be, I'll do this in blue, 1.972 would be right in there. Everybody agree with that?
Yes.
So 1.972, and then look at your t-value and find out what area you have to the right and to the left. All right, in your table, and that's going to give you 0.0568. So I'm going to draw that right here. So now the t-value table gives you area to the what? To the right. So that's going to be 0.0568. 0.0568. So somebody tell me what's to the left of the t-value. What's to the left? 0.9432. So make sure you know how to use your t-table. And that's all they're asking. They just want to know the rejection region. The rejection region is 0.0568. So what if you have a t-value? Is everybody listening? What if they give you a t-value of 3.2? Then you're going to reject the what? Null hypothesis. That's if they give you a value. They may not even give you a value. They might ask the question, find the rejection region, or find the t region, or t-value, or whatever. That's it. But you got to know how to use your t-value on your calculator, which we did in the previous questions.
Can we do it again?
We did it.
Like, can we do it again?
What did I give y'all videos for? Yeah, we'll do it again. It's just, forgive me, it gets toward the end of the semester and I just get kind of... I'll show you where it is again. Test, so go to stat, test, and what do we hit?
8.
T-test, thank you. Now, this is data, it's not data driven because you hadn't been given any data. So it goes to stat, enter, and there's your values. So, what is my M sub O?
100.
100. What is X bar?
104.
What is my standard deviation?
12.
And N?
35.
And not equal to, that's given to you. And calculate. Good?
Yes. Thank you.
So all I did was draw a picture of what? Of the of what the calculator gave you. Now that's if they just ask for a rejection region. So where is the rejection region? It's the blue. Okay? Now it is a two-tailed test, okay? But they're asking you where is that value at 1.972? Okay? Just a different type question. It's not a big deal. Chances are you probably won't see that one on the test. All right, here we go. I do have 4 questions. I'm sorry. I didn't know I had another question in here. All right, so the average test score in an entire school is equal to 75. The average test score for a whole school, school is equal to 75. So what did I just give y'all? Mu. Because it's of the whole what? School. School. You ever heard anybody say school? Oil. Mount Ann. Fountain Ann. I don't understand where they get those pronunciations from. Standard deviation is equal to 10. Oh my gosh, what have we been given? We've been given sigma. What is the probability that a random sample of 5 students scored above 80? So somebody tell me, what have we been given? We've got mu is equal to what? 75. We've got sigma is equal to 10, and we've got n is equal to what? 5, and we've got x bar is equal to what? What? 80. And the magic word or number here is what? So therefore, we're not going to use a t-score. We're going to use a what? Z-score. So go to it. So you have to go back to whatever last week's class was. I gave you those 3 formulas. P, then I gave you Z and T. Well, Z in forms of P and Z in forms of mu, and then T. And I told you when to use the T value and when to use the Z value. And for those of you that didn't write it down and didn't come to class and didn't watch the video, Z is equal to x bar minus mu over sigma divided by the square root of what? Now you put one proportion z-test, go to stat, test, one proportion statistic, and you type all this in. So let's go do that. Stat, test, one proportion z-test. Everybody with me? Enter. And what do you type in? It's not supposed to. Oh, I'm sorry. Not for one proportion. That's when you're given a proportion. I'm sorry. I'm stupid. There it is. First one. Z-test. And do we have data or do we have stats? We have stats. So what is our mu? 75. Our standard deviation is what? 10. Our X bar is what? 80. And our N is what? 5. And we want to see if the scores are what? Above. Calculate. There you go. And they give you a p-value, so all you have to do is look at the p-value. It's 13 cents greater, and they don't even give you an alpha, so they're not asking you to reject, or they're just asking you to find the z-value. So what is the z-value? 1.12, and the p-value is 13. 13 is above a nickel, and it's above 2.5 cents. So chances are you're going to what? Accept the null hypothesis. Okay? See the p-value? Now the question's not asking that. They're just asking you for a z-score. So the answer to this question would be 1 point what?
1.2.
Thank you. 1.12. Now, if they asked you what you know, well, we can write down the null hypothesis is what? We want a X bar is equal to 80 and H of A is X bar is what? Greater than 80. So it's a right tail test. So that's why you got 1.12. So you could draw a handy dandy rejection region of 1.12, which would be right in there. And there's your rejection region. But they're not asking you for that. All they're asking you for is a z-score. They want you to know the difference between a z-score and a t-test, the z-test and the t-test. Okay? But the p-value, what is 13 cents compared to 13 cents compared to 1 cent, 13 cents compared to 5 cents, 13 cents compared to 0.025, because those are the three most you're going to get. What are all of those? What is 13 cents? Greater than. So if the p-value is high, the null must what? Fly. So if they asked you, what would you say? You would say, I would fail to reject. Okay? Which means accept. Now, what if I gave you the same problem and the problem looked like this? Which I just changed one thing. Mu is equal to 75, N is equal to 9, S is equal to 10. Sigma is unknown, and I give you that information. You would automatically think what? T-test. And you would do T is equal to X bar minus mu over not the sigma, but S over the square root of N. And what is N? 9. Therefore, degrees of freedom is what? 8. And you would plug that in. I'm just going to plug it in by hand. 80, y'all do it on the calculator, minus 75 over S is 10 over the square root of 9, which is 3. And you crank that out. I didn't calculate it, but we'll do it on the calculator. So don't hit T interval because I'm not asking for a T interval. I'm just asking for the T test, T score. So let's go to our handy dandy calculator. Go to stat, test, and what? Not Z test, but T test. And make sure it's on stat. And go to 75, 80. Did they not give us X bar? Well, I didn't give it. Oh, I didn't give it to you. 80. Sorry. What's the standard deviation? 10.
Yes.
And N is equal to 9. And we want greater than because the original question said greater than. So calculate. I got 1.5. What'd y'all get? Okay. And of course, what's the p-value? 9 cents. So what is 9 cents? It's greater than all those others. Now, again, the question is not giving you a confidence or a significance level. It's not giving you that. But if it was, then you would say 9 cents is greater than whatever those other cents are, unless it was like a 75% confidence level. 95 is 0.05, which is normal. 0.05 is the one that everybody uses pretty much. 0.01, 0.025, those are the ones that are most used. So that's why I put those on top of the screen. So this would be 0.08, which is higher than all those, so you're going to fail to reject or accept the null hypothesis. But in this case, in this problem, T is equal to 1.5. That's the answer to the question. And the rest of the question, if you want it to go further, would be 0.09 is greater than 0.05, is greater than 0.01, and is greater than 0.025. Therefore, the null hypothesis is good. Question? All right. So here is where you put it together. And let me tell you something. I don't know how many of you are lobotomized, but this is where students get lobotomized. And you can see why I took out 10.1 through 10.4. Because their explanations are terrible. All right, so here we go. Average IQ is 100, population. Average population IQ is equal to 100. Researchers believe IQ is lower. They had 5 random samples. 5 random sample people, and they got 69, 79, 89, 99, and 109. So that means that you're going to type those in. Now, you can type them in and use the data-driven on the Z or T test, or you can type them in and find X bar and SX by yourself. However you want to do that, that's up to you. Okay? Is there enough evidence I can't spell. Evidence is there enough evidence that the average IQ is lower? These are IQ tests. That the average IQ is lower. So first of all, state your null hypothesis and your alternative hypothesis. Now, why are we going to use a t-test here?
Because we don't have
You weren't? Okay, so let's write that down over here on the side in red. Sigma equals what? Don't know. You don't have sigma. Therefore, so the degrees of freedom is equal to what? 4.
It's the number minus 1 times 1.
So what is the null hypothesis? Well, the null hypothesis is staring you right there. What is it?
It's H of O equals 100.
H of O, the mu, you have to write it correctly. I don't care, but you will have smart statisticians. They will go off if you don't write the mu there. And the alternative hypothesis is mu is what? Less than what? Now, we need to get a significance level. And I didn't give you one, so therefore you're going to assume 0.05 and write this in red. The reason you're going to assume 0.05 is a lot of times 0.05 significance level. The reason you assume 0.05, why don't I assume 99 or 0.01? Because that's a little bit too close to what? Perfect. Okay? Why don't I do 0.9 and get a 0.1? Well, that's a little bit lower in the bar. So a good happy medium is between 90 and 100, which is what? 95. So that's why 0.05 is used a good bit. So if you were given a question on a test or homework and there is no significance level given, usually it's going to be 0.05. Capiche? So that means you've got a left tail test, right? Yes, Hubert, we got a left tail test. So 0, 1, 2, 3, -1, -2, -3. And we've got to find our what first? We got to find our critical value. So look on your table or do a t-test with the given information. If you go to the table, you're going to look up 4 degrees of freedom, and you're going to go over to 0.05, and that's going to give you a t-value of 2.132. Y'all check me on the t-test on your calculator. Yes or no? Do I need to pull the calculator back up?
Yes.
Come on, people. Okay, I'm sorry. Y'all should be able to do the t-test. You just punch in the numbers. What am I missing here? I'm sorry. Maybe it's the drugs. Y'all know I'm known for being a deadhead, right? Dopehead, dumbass, whatever. All right, here we go. All right, is everybody looking? Is everybody looking?
Yes.
Who's the one asking to do it? Let's go down. Test, stat, test. Now, which one is it? T-test. We just did it. T-test. Like I said, y'all going to have to excuse me. It's the end of the semester. It's getting toward the end of the semester. And not only do y'all spaz out, but sometimes I spaz out. Now, what is data? Data means I need to type it in. Now, you can either type it in or you can find the mean and the standard deviation. Did somebody find the mean and the standard deviation? No. Okay. Well, let me go back and do the problem for you. Calculate or edit. And I'm going to type in these numbers. 69. 79. 89. 99. 109. Everybody with me?
Yes.
Okay, now I'm going to go to stat, test, t-test, and now I type in data, enter, and look at there, it's reading L1. Now, what do you type in? What's the mu? 100. L1 is our data. Frequency, you don't change. What's the alternative hypothesis? There's the data. Now, you got two things that are given here. I've done lost my page. Where's my page? Here it is. Okay, you got two things that are given. One is your test statistic. I'm going to wait till everybody is paying attention. Everybody get it? Everybody got negative 1.56?
Yes.
What is that? That is your test statistic. Write that down. That's number 4. Your test statistic. I tried to mix eggs and vodka this morning. It just didn't work. That's what it is. I guess out of how many days do we meet? 28 days we meet, right? I'm allowed to have one bitchy day, am I? Ain't I? One, maybe one. I don't think I've been bitchy with y'all, have I? I'll shut up. Okay. Now the reason I'm moving this, or I can't get rid of it. Okay. Anyway, so where is our rejection region? 2 point what? 2.132, right? So I'm going to draw. Well, first of all, let me do this. Number 1. What is the first rule? State your what? State your null and your alternative hypothesis. Step 1. Step 2. Find your critical what? Value. That's step 2. Now usually the critical value is either going to be a p-value, or it's going to be a t-value, or it's going to be a what? Everybody should be saying z, okay? Everybody, okay? Because we only got three tests, p, t, and z. Those are the three formulas, okay? So you find your critical value. Then you what? You draw a picture. 3, you draw a picture to show your what? Rejection what? Region. And our rejection region is 2.132. Now, what's the fourth thing we do? We just found it on the calculator. Test statistic. 4. Test statistic. Now, how do you find the test statistic? Well, that's where you type in or you figure all your values into. You don't look it up on a table. You don't look it up on the calculator. You type in all the values into the formula. In this case, it's the T formula, and you get a number. In this case, we did it on the calculator, z-test, I'm going to say z-test, or was it t-test? T-test. The t-test on the calculator, and it gave you what? Okay, I wrote it on the wrong side, I'm sorry. Down here, negative 2 point, I think I need to shut up. Negative 2.132, sorry, that's wrong. Okay, here is our test value. All right, now, where does the test statistic lie? It lies in the what region? The good region. So I'm going to take my handy dandy green, and that's 1.5. 1.55 is going to be right here. So what region is it in? It's in the good region, right? So you're going to what?
Fail to reject.
You're going to fail to reject. Now, what other value tells you to fail to reject? Hold on, let me turn. Thank you, the p-value. So if the question asks you, I'm trying to do all this on the calculator, move all this around. What's the p-value?
0.09.
It's a dime, right? 0.09, a dime. Is a dime greater than 5 cents?
Yes.
So if the p-value is high, the null will fly. That is a question on the test right there. Okay? Except for my screw up on the wrong side. I'm sorry. It's lower, so it be on the left side. That's why it's negative. Sorry. All right, so you got 1. What's the first step?
Interpretation outside.
State the null hypothesis, okay? State the null and the alternative. So let's write that down. State. Whenever I minimize this thing, it goes crazy and it doesn't write very well. All right, so the first step is to state the null and the alternative hypothesis. Second step, the critical value. The critical value is usually found with a table. Or you type in t-test or whatever, and it'll give you that 2.132. Okay? Then you draw a picture. Then you do the test statistic. In this case, the test statistic, if you did it by hand, let's see if I did it by hand. Yes, I did. For you. Okay? In this case, it's going to be T equals 89 minus 100 over 15.81 divided by 5, square root of 5. I don't know where I got 15. Where did I get 15.81? That's standard deviation. You didn't calculate that. That's where this is the standard deviation. Sx is equal to 15.81, and the mean is 89. Did somebody check that?
Yes.
X bar is equal to 89. There we go. Now, if this was given, then you would punch it in there, okay? With the test statistic is usually the one you have to calculate. Remember that. You have to calculate it. Usually the critical value is found with the table. So that's one question that you may see on the test. Now I gave you about 10 of these on the homework. So you should be able to do them. By the time you get through doing 10 of them, you should be able to do 2 or 3 on the test. Okay? And we've got Tuesday, and I will be sitting in here Tuesday for those of you that what? Need questions. The only way I'll get mad at you if you ask me how to do a t-test again. No, I'm just kidding. I'm going to get rid of this. I think I'm just tired. All right. NFL believes the change, okay, they believe that the Patriots are cheating with the coin test. This is a made-up question. Okay? So, NFL believes that the coin toss is greater than 50%. NFL believes that the coin toss is greater than 50%. Okay, in a random sample, a coin was tossed 200 times, and the Patriots won 118 times. Is there enough evidence? Is there enough evidence that the Pats are cheaters? This is a made-up question, okay? First of all, there's two things you need to realize here. Do they give you a bunch of mean, median, mode, range? They don't give you all that stuff, do they? What do they give you? And X. So you need to be thinking to yourself before you state the null hypothesis. Over here, you need to say no X bar, no mu, no standard deviation, no sigma. All you're given is X and N. Therefore, this is a p-test. So that means you're going to find the z-value with a p-test. So, first of all, state your null hypothesis. Null hypothesis, H of O, is that P is going to be equal to what? 0.5. Therefore, H of A, P is what? What do they say here? Greater than what? Greater than 0.5. So there's part one. Now, we're going to do a 0.01 confidence interval. So I'm going to put that in. Alpha equals 0.01. We know this is a right tail test, so we don't have to worry about alpha over 2. So it's a right tail test. So let's draw a picture. So I'm going to draw a picture. Now, somebody look on your handy-dandy index card and tell me what alpha 0.05 is equal to, 0.01, sorry. On your index card, the one that I told you to write out, did everybody write them out? Yes. Hell to the no. Yes. I guarantee you're probably happy you did it.
326.
2 point what?
326.
Good job. 2.326 is your critical what? Value. 2.326. So therefore, what's our rejection region? Everything to the what? Right, because this is a what test? Right tail test. So we just found our what? We just found our critical value. That's step 2. Critical value. And we drew it. So now all we got to do now is what? Starts with a T.
T score.
Test what? Test statistic. And that's where you have to type in everything into the formula. What formula? Well, it's a P formula. So Z sub P, that's that first formula that I gave you the other day. There's 3 formulas, is equal to, and you can do it on your calculator also. I showed you how to do that. P hat minus P over square root of PQ over N. And what's P hat? Well, we got to calculate it. Well, go up here. P hat is equal to, well, that's pretty simple. What's the only values they've given you? 118 over what? And somebody give me that decimal to, let's see, I've got to 2 digits. 0.59. So that P hat is going to be right here, 0.59 minus, what's P? 0.5 over 0.59 times 0.41 over N is what? 200, sorry. And that's the square root. Somebody crank that out. And when you crank that out, I get 2.55. Somebody check me. And that is our test what? That's our test statistic. And let's plot it. Where is 2.55? Let's see, there's 1, there's 2. Womp, womp, womp. What does that mean?
That means that you
reject because it's in the what? Rejection region. Y'all remember me putting an arrow right here and saying rejection region? Y'all remember that? Yes. Okay, so if something falls in the rejection region, what do? Reject the null hypothesis. I know it's a lot, but look on the bright side. You could be using your book. You don't want to use your book. Okay? Now, when y'all come back Tuesday, all we're going to do is homework questions. If you don't want to be here, don't show up. If you want questions, if you want to go over questions, show up. Everybody with me? Yes. All right. Y'all have a great Thanksgiving and be careful. Keep between the ditches. I had to explain that one time, what keep it between the ditches means. Yes, ma'am. Y'all forgive me for being a bitch today.
When you just pulled that up, when we had all that information, don't get mad at me.
I'm not mad at you. I'm being bitchy. Okay? No, not you.